the Linux rescue and recovery process. In this nugget, we're going to talk about the Linux rescue process. We'll learn how to boot into the Linux rescue process. We'll talk about what commands are available to us, how the file systems are arranged, that sort of stuff. And then we'll actually go through and break something and fix it, and you'll get a sense of how the Linux rescue process works. All right, well, let's get down to it. All right, well, let's talk about the Linux rescue process in some general terms here to give you an idea of what has to go on to get into the rescue mode and what you're going to do once you're in there. Then we'll move out to the Linux screen and actually follow through and do some of this stuff. So the first thing is you need some sort of a boot disk, either a floppy boot disk or the CDs that your distribution came on to boot into rescue mode. The floppy boot disk you can create during an installation. That's one thing. Another thing that you can do is that you can actually create it after you've already installed Linux, and I'll show you how to do that in this nugget. Then once you boot up off of the rescue disk or off one of these boot floppy or boot CDs, then what you can do is get into Linux rescue mode. And once you're in there, some useful commands that you should know are fscheck for file system check, fdisk, which we've already learned. Actually, we learned both of these back in I think it was the second nugget of this series. And the file system check has to do with checking and repairing file system. Fdisk deals with partition information, displaying partition information, altering partitions, things like that you can do with fdisk. E2 label has to do with seeing labels on or changing labels on a particular partition, and then sync has to do with writing out information that's in memory out to disk. So a lot of times what happens is when you're doing a write, like you're editing some file and you say save it, and then what happens is the processor or the computer hasn't really written it out to disk yet. It's just written it to a buffer in memory, and by using the sync command you can force that buffer in memory to be written out to disk so that your changes are actually saved to disk. Okay, so there's an overview of the Linux rescue process. Let's move out to the Linux screen and talk about first how to create a boot floppy after you've already installed Linux, and then we'll go through and actually look at the rescue mode in more detail. Well, the first thing I want to do here at the Linux screen is show you how to make a boot disk after you've already installed Linux. Okay, so like I told you before, when you're doing the installation, you have a choice to make a boot floppy disk, but perhaps you chose not to do that at the time, or you did it and now you've lost your boot floppy and now you need to make one. Okay, so before we do that, let me just make another note here, is that you can see the machine that I'm on for this nugget is called Nugget Rescue. This is a new machine. I'm not using the same machine that I was using for previous nuggets and that I'm going to use again for future nuggets, because some of the stuff I'm going to be doing in this nugget could cause data loss and stuff. I'm going to break some things, make it so I can't boot into my system and so on, and I just wanted to use a separate system so that I didn't mess anything up in some unfixable way. Okay, so if you're going to follow along and do some of the exercises that I'm going to do in this nugget, then I suggest either installing Linux on some old machine just to practice on, or if you only have one machine at your disposal and you feel like you want to practice some of this stuff, then make sure you have a complete backup of your system right before you undertake this. Okay, so that's our machine Nugget Rescue for this particular nugget, and what we're going to do first, like I said, is make a boot disk. All right, so first I have to be the root user to do this, so I'm going to switch over to be the root user, and then the command is called make boot disk. Okay, and it's in the /sbin directory. Of the what's involved if you don't have this auto mount your old file system under mount sysimage. Okay, so like I said, I'm going to hit continue for now, and now it says your system has been mounted under mount /sysimage. So if I just press return here, I get a shell, and when I exit from the shell, the system's going to reboot automatically. Okay. Now there's a command called change root that they're talking about here. So if you would like to make your system the root environment, run the command change root mount sysimage anytime you want once you're in the shell. And what change root does is it says make the new root of the file system, like the / directory, make that equal to this directory here that I'm writing. So if I said change root mount sysimage, then the root of my file system will be sort of the old root of my file system, and I can work from there if I wanted to do that. Okay, so I'm going to click OK here, and now we're at the bash shell. Okay, and you can see it's okay. The system's mounted under mount sysimage. When it's finished, please exit from the shell, and your system will reboot automatically. Okay, now we're going to move out to the Linux screen to the shell window live again, so you can see me do some of the stuff, and we're going to poke around in the rescue environment and sort of see what's there. All right, so here we are in the rescue environment. We click continue back at that last screen, so it told us that it was going to mount our old file system under /mount/sysimage. Okay, so let's just look around here a little bit. Let's see what our working directory is. We're in the top level directory, and if I do an ls here, you'll see a bunch of familiar subdirectories, /bin, /dev, /etsy, /live. However, these are not the same directories as those that were in my original file system. Okay, those directories, like we just said, were under /mount/sysimage. Okay, so under mount sysimage, there's bin, boot, dev, etsy, and so on. Those are the subdirectories from my original file system, my actual Linux file system. The ones up above from the actual /etsy directory, for instance, is in some sense like the rescue mode etsy directory. Okay, so if I do an ls of /etsy, that's the rescue mode etsy directory. It only has a handful of configuration files, just like the most necessary ones for rescue mode. Okay. Now, if you want to see, for instance, what commands you have available to you in rescue mode, well, you can do things like ls/users/bin or something. Okay. Let me pipe that through more. And these are commands that you have a configuration file change that you made that was an error. Okay. That wasn't, you didn't do the right thing. And so anytime you make a change to a configuration file that is a critical configuration file, like grub.conf or like some file system table configuration file, something like that. Anytime you make changes to those kinds of configuration files that affect the booting process, you should go back and test right away after you make those changes to make sure that the system still boots up. There's no other way to test those changes except to make sure that your system boots. So if you go ahead, your system boots up great, you make changes to, say, grub.conf and the file system table configuration file and so on, and then you don't reboot your system for like a month, and then in a month you come back and boot your system and it doesn't boot up. Well, why? What happened? Well, it could be a whole slew of things, and it would be nice if you could eliminate the configuration file changes as a possible problem, and the way that you can do that is after you make the changes to those kinds of configuration files, you immediately reboot the system to test to make sure that your changes were correct. Okay, so while this event right here is completely staged, it does fall into the realm of the kinds of things that happen that make your system not boot up. Okay, so I'm going to press any key to continue here, and then what I'm going to do is put in the distribution CDs again, and I'm back to like this first screen of when you boot off the CD. I'm going to type Linux Rescue down here, just like we did before. Now the system's booting up, and now it's loading my rescue mode after our system didn't boot. Now let's go back out to the shell screen again and fix the problem that we created and learn some other stuff about some of the commands that are available to us in rescue mode. Alright, so now here we are in the minimal rescue mode. Let's just look at some of the difference between this rescue mode and the normal rescue mode that we were just in a few minutes ago. If I do an ls of the top level directory, you'll see the exact same subdirectories that we saw in normal rescue mode. What you won't see, though, is in the mount directory, you won't see the /sysimage subdirectory because we didn't choose to mount our file system under /mount/sysimage. Okay, so that's one thing. That's like the major difference between minimal rescue mode and normal rescue mode. Now, why would you not want to have the system automatically mount your old file system under mount sysimage? Well, one of the reasons why you might choose to do that is because the files, if you're going to do a file system check on a file system, it can't be mounted. So if you suspect that one of the file systems or one of the partitions of your old file system is corrupt and you want to do a file system check on that, then it can't be mounted, so this is the way you would proceed. You would choose skip at the last screen when you were saying whether you want to mount the old file systems or not. You'd get into minimal rescue mode, and then you can do the file system check on those particular partitions that you want to check. Okay, so let's look at, use the fdisk -l command. We talked about fdisk back, I think it was in the second nugget of this series. And this is going to list all of the partitions that are on our normal file system. So you can see there's SDA1, SDA2, and SDA3. What we can do here, we can run a file system check on a particular partition. E2FS-check is a variant of file system check for extended to file systems, which these file systems are of that type. So I'm going to run E2FS-check on /dev/SDA1 and see what comes up here. And you can see what it says. It says clean 42 out of this many files, this many out of this many blocks, and so on. Okay, so the file system check proceeded, and the only reason I could do that file system check is because the file system itself was not mounted yet. Okay, another command that I talked about before was the E2label command. So using E2label, we can look at /dev/SDA1 and determine what mount point that partition has. So there we do that, and we can see that partition, SDA1, has a mount point of /boot. And we can do the same thing. Make the changes to the grub.conf configuration file, then we'll reboot our system and see that everything's fine. Okay, so I'm going to use the VI editor, and I'm going to edit the temp mount etc grub.conf configuration file. Okay, now remember, this is all staged. I broke the grub.conf configuration file on purpose so that I could show you some stuff about rescue mode. Okay, what you would be doing right now in reality is, deducing what the problem is, what changes you need to make, that sort of thing. And the only way to really get good at this sort of stuff is to practice. Okay, and if you haven't had enough experience using this sort of thing, well, you can read case examples on the internet of how people changed their system or why their system didn't boot up, the solutions they went through to make their system boot up properly. Okay. Now that being said, a lot of the problems that result in this sort of situation, the reason systems don't boot, is because of user error. Okay, like you made some change to a critical configuration file like grub.conf or the file system table configuration file, and then your system doesn't boot up anymore. Well, that's your fault. The moral of the story here is don't let the problems linger. If you make a change to grub.conf or some other file that affects the boot process, go ahead, after you make that change, go ahead and reboot the system right then. Okay? If you immediately reboot the system and it doesn't boot up, then you know exactly what configuration file it was that is the cause of the problem because you just changed it. Okay? Whereas if you make a change to grub.conf today and the file system table configuration file tomorrow and some other file, some other critical configuration file in a few days, and then next week you go to reboot your system and it doesn't boot up, well, you don't know exactly which configuration file it was that caused this problem. Okay? So if you're ever making changes to these critical files, reboot the system, don't let the problems linger and end up causing yourself more work, because then you have to deduce exactly which change it was or which combination of changes it was that caused this thing to not boot up. Okay, so now let's actually go and make this change. So I'm going to use VI to edit this file because VI is the only editor that I have available to me in rescue mode. Okay, if you're not really familiar with the VI editor, like for me, for example, I use Emacs all the time. So VI is not really commonplace to me, but I keep enough commands, VI commands fresh in my mind so that I can do the basic stuff in VI, like, use VI in rescue mode. If you don't ever use VI, at least have a cheat sheet or a book around or something to keep, so that you have the commands available to you so that when you go into rescue mode, you can actually do something with the VI editor. Alright, so I'm going to hit enter here, and now I'm in the grub.conf configuration file. I'm going to hit the down arrow to go down here. I'm going to hit X, and I also showed you first how to make the boot floppy if you chose not to do it during the installation process. And then we talked about the three variations of rescue mode. The basic rescue mode was that it would mount your old file system under mount/sysimage as a read-write file system, so you could go in there and make changes. The other option was that you could mount your old file system under mount sysimage, but mount it as a read-only file system, so you could just look and see what's wrong, but you couldn't make any changes. And the final variation was you didn't mount your old file system at all. And the reason you might want to do that is so that you can do a file system check on the various partitions of that file system. And I showed you some of the ways that you can do that. Then we talked about the available commands in Linux rescue mode. We walked through an example of actually fixing a configuration file and then writing our changes and rebooting the system, and we saw how that worked. One of the commands that you shouldn't forget is that sync command, because sometimes you can make the changes, you can identify the change and make it, but it doesn't get written out to disk because you didn't force the buffer, the memory buffer, to be written out to disk before you rebooted. So keep that sync command in mind, and remember, a lot of people suggest that you do sync 3 times to make sure that you flush those buffers and write them to disk. All right, well, I hope you found this nugget informative, and thanks for watching.